Good morning, learners. This morning, we will have another topic of our statistics and probability. But before that, let us have the opening prayer to be given to us by Mr. Darwin. Alright, class. Since we are through with our prayer, and we will check first your attendance. So, may I know the attendance now, class Bidol? Yes, very good. So, all are present this morning. So, first, we will have an activity. And remember that I give you an assignment last meeting that you have to bring any coins from your house. So I will divide the group into, or the class, I will divide the class into two groups. We have Team A there, and we have the Team B in the left side, in the right side. So for Team A, what are the coins that you have there? Oh, very good. You have the 10 centavo, and also you have the 5 centavo. How about in the Team B? What are your coins there? Oh, very good. So you have the 1 peso coin. You also have the 50 centavo coin. And also we have the 15 centavo coin. So, very good. So, this time, you are going to take a random sample of your coins that you have. Take a random sample of size 2 from 4 random selected coins. Complete the table given. Construct a histogram based from the mean and frequency. So here we have the sample mean, the frequency, and the probability. Next. So what have you? Are you through? Team Group 1, are you through? Not yet? How about the Team Group 2? Oh, still computing. So I'll give you 5 minutes for the solution of the sample mean, frequency, and the probability. So remember that in sample mean, you are going to add the given sample, then you divide it by how many population, or the number of population there. For the frequency, so you are going to write how many times does the number occurs. Then the probability is how many times that it occurs over the total number of samples. Alright, class. Can you still recall what is a random sampling? Yeah, Mr. Kabaran? Yes, very good. So, a random sampling is a process of getting a sample which are good representatives of a population. Yes, very good. So, how about why is is there a need for a random sampling? Miss Mikaela? Yes, very good. There should be a need for random sampling in order that we can have a, a bias in getting a sample from the population. So you must have a random sampling in order that each individual has a chance of selecting or choosing from in getting the sample. So let us recall what you have learned about combination, because in getting the sample sampling distribution of the sample means you need to have the skill in solving the combination. So can you still recall what is the formula in getting the combination? So I have here the formula, so nobody can recall the formula in getting the sample. So we have here the combination formula. So we have C refers to the combination, and we have capital N. We have here the number of observations. So we have N for the number of observations. And we have the small letter n for the size of possible random samples. We have here the size of the possible random samples. So we have C sub n. We have it n here for the number of observation is equal to n factorial, or capital N factorial, divided by the quantity of n, the number of observation, minus small letter n, which is the size of the population, times n factorial. So that will be our formula. So we have n factorial quantity n minus n enclosed, then factorial times n factorial. Let us have an example for that. So there are 6 students have the following grades in English. So we have 6 students. So we have 6 students have the following grades, no? Have the following grades in English. So these are the following grades. So we have 89, we have 84, we have 90, we also have 93, 86, and 82. So these are now the data. We have here the grade of the 6 students in English. So what we have to do now is we are going to list down all possible random sample of size 3. So we are going to get the possible, we are going to list down the possible random sample of size 3. So remember that we are going to list down all the possible random sample of size 3. So this is now the sample size, or the size of the possible random sample, which is size 3. And we have the number of observation is equal to 6. Our n, which is the size of the possible random sample, is 3. So following the formula of combination, so we can solve that one. We all know that our n in the given problem, we all know that n is equal to 6, capital N. The small letter n refers to the size of the population, which is 3. So following that formula, so we will have here n, C sub n is equal to the n factorial divided by the quantity n factorial minus n factorial times n factorial. So we substitute the given. So we have the n factorial, we have 6 factorial divided by n, which is 6, minus 3, our size of the population. And we have factorial, then n, which is 3, which is the size of the possible random sample. So we have 3 factorial. So we know that 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1 over subtracting 6 minus 3, and that is 3. So we have 3 factorial times 3 factorial. So copy that one. We have 6 times 5 times 4 times 3 times 2 times 1 over 3 factorial, that is 3 times 2 times 1. Enclose, we have 3 factorial, another 3 factorial. So we have 3 times 2 times 1. So we are going to divide this one using cancellation method. We have cancel this one and this one. And we know that 3 times 2 is 6 times 1 is 6. So we can cancel out this one and this one also. So the answer now is 5 times 4, and that is 20. So there are 20. So there are 20 possible random samples. So there are 20 possible random samples based on the given problem, that we are going to find the list of the random samples of size 3, and the given population, we have the n is 6, since 6 is the number of students, and small letter n is the size of the possible random sample. Then we show the solution, and the answer is there are 20 possible random samples. So how can we list down? So after solving the possible random samples given the formula of the combination, we are going to list down first, no? So we are going to list down all the possible random samples. So of size 3. Remember that the size of the population or the random sample is 3. So this is now the population. We have 89, 84, 90, 93, 86, 82. So we are going to get the possible So we have here the possible random samples. We all know that the result is 20. 20. So let's start. We have 89, 84, 90. So that is our first. Second, we have 89, 84, 93. Then 3, 89, 84, 86. 4, 89, 84, 82. Next, number 5, we have 84, 90, 93. Next, 6, 84, 90, 86. 7, 84, 90, 82. And so on. So after these are the possible random samples, and we all know that there are 20. So you may solve now the rest of the combination or the list of the random samples. After knowing that, we are going to solve. We are going to solve the random samples of size 3 by getting the sample mean. So we all know that this one, so I will erase this one. So we have here the random sample. Next, we have here the sample mean. So this is what we're going to do first, no? First, we are going to get the random sample of size 3. So we have here the given. Then we will get the sample mean. So how to get, so all the possible random sample will be written here. So for number 1, we have 89, 84, 90. So for the sample mean, we are going to add the given sample size of 3. So the random sample number 1, 89, 84, 90, we are going to add at 1. So 89, 84 plus 90. So we have 13, 1. So 16, 7. We have 6. So on 2. So 263. So we are going to divide it by the number of population, which is 3. Divided by 3 to get the sample mean. So we have 26 divided by 3. So that is 8, 24. And this one is 23, 7, 21. So we have 2, 0. So we have 20. So that is 0.6. Then 18. Then 2. So 6, so 86, 87 was 67. So the score there is, we have here the 87.67 as the sample mean. Then next, and for number 2, just the same, you are going to add the sample, the random sample of size 3. After adding, you divide it by 3 since we have in the size 3. Then after that, so after solving all of this, all the 20 possible random samples, we are going to Sige, okay, no? You are through with that one. So let's have another example. So let us, I want now group 1, anybody from the group that will answer. But before that, let us have I will write on the board the given problem. So we have here the problem number 1. So we have a certain population consists of the numbers 3, 6, 7, 12, and 4. Next, you are going to construct sampling distribution of size 3. So this is now your problem. So you may now start solving now. I will give you 5 minutes to answer the given problem. So do you have any problem of the one that we discussed by giving the number of possible random samples? So you just only use this formula of combination in order for you to know the exact possible random sample. I will wait for that for in answering that one. So we all know that. So are you through? Yes. Group 1 will solve the given problem. Yes, very good. Thank you for the given solution, group 1. Do you have question? How about group 2? Do you have question? You're not able to construct the histogram of the sampling distribution of the means. So I will show you now how to construct the histogram of the sampling distribution. So we have here. So this is now the histogram of the sampling distribution of the mean. So we have the sample means here below. So you're going, all the sample mean will be written at the x-axis, while the probability, since we are going to have the probability as the next column, will be written at the y-axis in constructing the histogram of the simple distribution of means. So this time I will give you a problem. Each group will be given problem, and after solving the given problem, you are going to present your work on the board. So I'll give you 10 minutes to solve your given problem. So I will give problem number 1. So it's being written there on the board. For the group 1, it's for problem number 1. For group 2, we have problem number 2. It's written on the board. Be sure to still use the formula of the combination in order for you to get the random samples of size 3. After that, so you are going to have the frequency. Then after that, you are going to have the probability. And after that, you can use the mean and the probability in order for you to construct the histogram. Yeah, thank you. Group 1. So let us have the presentation for the group 1. Very good, group 1. How about for the group 2? Yes, very good, group 2. All are correct. So we all know that. Do you have a question? Yes, and so let us have evaluation. So I have here one problem. I will read the problem and you are going to answer this one. A population consists of 5 numbers, 2, 3, 6, 8, and 11. Consider the sample of size 2 that can be drawn from the population. So letter A. This is the first one that you are going to do. List all the possible samples and corresponding means. So meaning you are going to find the possible samples and you are going to get the mean. Another, you have to construct the sampling distribution of the sample mean. Then draw a histogram of the simple sampling distribution of the mean. I will give you 5 minutes to answer that. Yeah, okay. So everybody, pass your papers now. And for your remedial, for those who got lower score, we'll have here the remedial. We have here for your remedial. For those students who got high, will be given for enrichment. For you to understand more, and you will discover more about how to solve the sampling distribution of the sample means from a finite population. And for your assignment, on your journal notebook, feel free to write about the difficulties that you encountered for the lesson, if there were any. Next, the strategies you use to overcome these difficulties. Lastly, the things to be clarified. That's all for today. Thank you. And this is Ceremony. Say goodbye. Goodbye, class.